4 and 1 make 5. And then I'm going to break up my q's. Again, this is a fourth root, so I can try to figure out multiples of 4 here. So I got q to the 11th. I know I can do q then to the 8th. That goes into 4. And I have 3 left over. So again, remember on this one, I can simplify these 2 radicals. The other ones just have to stay put. So this is going to be 14 and then 4 for the p. It's 4 over 4, power of a root. So it's going to be p to the first. So that's gone. For the q, it's going to be 8 over 4. So it's going to be q squared. And you're left with the fourth root of pq to the third. Again, it's p to the first, q to the third. And you don't need the 1 there. Again, if you're wondering why you don't need the 1 on the p, the only way you'd be cubing the p is if you had this in parentheses. So if it's written the way I have it written here, it's a given that the p is not being cubed. Again, I would have to have parentheses to make that a given. So this is p to the first, q to the third. You are all set. So as I said, that's multiplying. Now this is with monomials. I have the multiplying with binomials here, but you'll see these are actually, again, the multiplying is probably the easiest part as I'm trying to get across here. But now we're moving into binomials. So starting with number 18, when you're dealing with binomials, the concept that we already know here is FOIL. So we're still going to be foiling with these. So when I do this perfect square, I'm going to go 4 minus radical 5. And then times 4 minus radical 5. So I'm not doing anything majorly different. This is just going to be FOIL. So I'm going to go 16, first terms, minus 4 radical 5, outside terms, minus 4 radical 5, inside terms, and then my last terms are going to be plus, and then again you multiply a radical by itself, it's going to just give you 5, or you can say the square root of 25, but I'm going to say 5. So I have 16 plus 5. You combine like terms now. We're now adding, subtracting. So I'm going to use my cat rule. The terms have to be the same for me to combine them. So 16 and 5 are both constants. So that's 21. And negative 4 is minus 8 radical 5. I said nothing much here. Just FOIL. Okay, and then 20. FOIL this. Radical x and radical x is x. That's your outside terms, or your first term, sorry. Your outside terms, next up is going to be positive, so plus the square root of 2x, because I'm multiplying now, so I don't care if they're not like terms, I just multiply them together. Next up, I have minus the square root of 8x, and my last terms are minus the square root of 16, 8 times 2. Again, you multiply, who cares if they're alike or not, you just multiply them. Don't really worry about it. Now I have to add and subtract. So before I can do that, I have to do some I can't talk right. I have to do some simplifying. So one thing I do see is that 8, that is going to be the square root of 4 and 2. So if I break that radical up, you'll see 4 times 2 times x there. And obviously I got a perfect square at the end, but let's do this first. So I have x plus the square root of 2x minus the square root of 4. Well, that's going to be 2. So 2 square root of 2x, because the 2 and the x were staying put. And then minus 4. Notice here I do have 2 like terms. I have these radical 2x's. This is technically a 1 radical 2x. So I'm going to go x, and then 1 minus 2 is minus 1, or minus the square root of 2x minus 4. Notice that is about all I can combine. I got my x term, I got my radical term, I got my constant. None of them are like terms, so that's your final answer on number 20. That's about as bad as those multiplying ones can get, honestly. Okay, so that's going to be adding, subtracting, and multiplying. The last piece that we have here is dividing radicals. So dividing, that fits in that dog family. So again, we don't worry as much about like terms. We just need to divide. Divide your constants, divide your radicals. That's about all you need to worry about here. So you'll see divide, make sure you use quotient rules when applicable, and then simplify. That is it. So number 2 here, we simplify 36 divided by 9. So we know they're both divisible by 3, so I can cancel out a factor of 3 from both. So that would be 12 and 3. Actually, 9 goes into both. I should probably just do that. So 9 goes into 36 4 times, so that's just 4 and 1 actually. And then 1250 divided by 2. Again, that's going to be in the radical, but you just divide those terms. So this is going to be 4 and then the 4th root of 625. Again, just divide the numbers and divide the radicals. And that's it. And you just got to simplify. So I know 625, that is one of your perfect force. If you don't see it, you can go 625 divided by 25, and you'll see you get 25. So this is actually 5 to the 4th, if you kind of broke it down a little bit. So I end up with 4 times 5, which is 20. Simplify. And excuse me on that. Again, I can't edit my video, I'm sneezing. So that's number 2. And kind of following the same process here, we're going to number 3. Again, this just reminds you on number 3, make sure when you simplify, use your quotient rule, which means when you divide, you subtract your exponents. So when I'm when I'm dividing here, I'm going to get inside the square root x to the 3 halves, or 3 divided by 2, so 3 minus 2. And y to the 9th over y to the 5th is y to the 9 minus 5. So again, simplify this out. We get the square root of x, and then that's to the 1st, and y to the 4th. Okay, now, once you do the division, literally I just divided everything. This is a square root, so I can pull out the y to the 4th. This would be, by the way, y to the 4 over 2 times the square root of x. So that's y squared, square root of x. Again, if you're good at simplifying radicals, this is kind of a quick process here. So again, it's part of that dog family. Just divide as you see fit, and you should be okay. And the last piece, and this is what we'll wrap up. So when you are dividing, and you end up with radicals that are in the denominator, that's part of that concept. We've already talked about it before. So this is review of rationalizing denominators. Now there's two situations that we may see. One is if you have a monomial in the denominator, we're going to multiply the numerator and the denominator by that radical. We're just trying to get rid of the radical in the denominator. That's what rationalizing means. The radical needs to be out of the denominator. If we have a binomial, again, we've done this with our imaginary numbers already. We're going to multiply the numerator and the denominator by the conjugate. So you'll see that in a second, but we've already done it, so you should kind of recognize it as we do this. So with this binomial rule, I want to remind you we're basically using this factoring concept. A plus b times a minus b, that equals a squared minus b squared. I don't like to FOIL this. I want you to know the difference of squares rule, because we use it so much, it's just best to know it. So number 11 is a rationalizing problem with a monomial in the bottom. There's nothing I can divide. 3 and 4 don't divide. 12 and 7 don't divide, so I'm just going to rationalize. So if you have a monomial, we multiply the top and bottom by the square root of 7. Notice I'm not multiplying by the 4. I can multiply by the 4, but I would just have to end up canceling that 4 out later on. Because it's just gonna have to cancel regardless. So there's really no point in multiplying by the 4. It's the radical I need to get rid of, not the 4. So this becomes 3 times the square root, and I'm just gonna go 12 times 7, which is 84. And down on the bottom I get 4 times the square root of 49, which is 7. The radical kind of cancels that out. So we end up with 3 square roots 84 over 28. You could try to simplify 84, but here's the thing. 84, actually it does simplify. I should have done that already, my bad. But again, I can't edit, so it's fine. So I'm going to try to simplify this. I would have probably simplified it at the very beginning because I could already see that 12 is 4 times 3. So I could have already pulled this out, but since this is where we're at, I'm just going to divide 84 by 4. So this is going to be 3 and then the square root of 4 times the square root of 21. I'm just going to do it now. No big deal. This is 28 on bottom, so we'll go from there. So the square root of 4 is 2. So I have 3 times 2 times the square root of 21, which is 6. So I'm simplifying that. Now, the last thing here, I want to see, can I simplify maybe my constants? And you can, because they're both even numbers, so I know I can at least pull out a 2. So I will do that. So I'm going to pull out a 2 from the top and bottom. So that would give me a 3 on top and a 14 on bottom. So I get 3 square root of 21 over 14. By the way, don't get overzealous when you're doing division. Say, I'll just divide everything. And you start dividing 21 and 14, for example. You can only divide the terms that are inside the radical by the other terms that are inside radicals. And you can only divide your terms on the outside of the radical by other terms that are not in a radical. So I can only divide 3 and 14. I cannot divide the 21 and 14. So be aware of that, because the square root of 21 is not 21. It's actually a really ugly number, so don't try to do it. Actually, it is 4.582. So 4.582 doesn't go into 14. That's why we can't divide those. So again, don't try. All right, that's a monomial, and here's a binomial. So we've done this before. We multiply, and we have a binomial on the bottom. We have a binomial because we have this plus or minus in front. And we're going to multiply this by the conjugate on top and bottom. So I'm going to multiply the top and bottom. By the way, don't do that. Don't you dare do that. Okay, now that I got that out of the way. By the way, this is divided by this entire term. So unless I have a 4 plus radical 2 on top, you can't cancel any of that out. Anyway, we're going to multiply this by the conjugate, though, and see if we can simplify some stuff maybe later on. So I'm going to multiply this by 4 minus radical 2. That would be the conjugate. You change the sign. If this was a minus to begin with, I would make that a plus, or vice versa, which is what I have. So I have this plus, I made it a minus. So on top, I am going to distribute the 4. So it'll be 16 minus 4 radical 2. I may even want to keep the 4 on the outside, maybe not even multiply it through. You'll see why in a minute. On bottom, though, I get a squared minus b squared. So a squared is 16 minus b squared is radical 2 squared, which is 2. So at this point, I have 16 minus 4 radical 2. 16 minus 2 is 14. And looks like, I can't pull out a 4 on top and bottom, but I can pull out a 2. But again, you can write this a couple different ways. One way you can do it is this. You can pull out a 2 out of the numerator. That would be 8 minus 2 radical 2 over 14. And the 2 and the 14 cancel. So you get 8 minus 2 radical 2 over 7. So that's one way of doing it. The other way you can simplify this is like this. You can go 16 over 14 minus 4 radical 2 over 14. I'm breaking the fraction up. And 16 over 14, well, that's going to be 8/7. If I can do that right. 8/7 minus 2 radical 2 over 7. And then you can just combine it from there. So a couple different ways you can do that. Just want to show you. But make sure you get your same answer when you're done. Okay. And number 20. So number 20, we have 8 minus radical 6, and then 3 minus 4 radical 6. Same thing here. I'm going to multiply the top and bottom by the conjugate. So that means I'm going to multiply the top and bottom by